Let's take a look at your MT7 LT3 seminar. Before you start, do the first 5 questions. We'll review them in class. And what we're going to do is we're going to solve our systems by elimination. We're going to do this over the next 2 lessons, each one getting a little bit more complex. And when you solve a system by elimination, you're just adding the same thing to both sides. So for example, if I have like 4 plus 3 equals 7, and 10 minus 2 equals 8, if I add those 2 equations up, I'll get 14 plus 1 equals 15. I've just added the same thing to both sides, so we'll get another true equation. That's what we're going to do with elimination. When we do elimination, first thing you're going to do is you're going to make sure your variables are lined up in columns. Then you're going to add them and solve that new equation. And then you're going to substitute that variable back into one of the equations to find the other variable. So let's go through this. Notice in example 1, see how my y's are lined up? So are my x's. Actually, so are my numbers. So and notice my y's are going to cancel, aren't they? Because 5y minus 5y is 0. But I'm still going to add the others. 3x plus 5x is 8x. And 11 plus 5 is 16. So I divide both sides by 8. And x equals 2. Now I got x. Now I'm going to use x to solve for y. I'm going to pick one of my equations. I like the first one. So we're going to say 3x plus 5y equals 11. Only now we know x is 2. So it's 3 times 2 plus 5y equals 11. 3 times 2 is 6 plus 5y equals 11. You can minus 6 from both sides. And you get 5y equals 5. So I'll divide both sides by 5. And y equals 1. Since I have x and y, I'll write it as an ordered pair. So in other words, if I graph these two, that's going to be where they intersect. And then let's take a look at example 2. Example 2 is more of a word problem, well, a number problem, really. So what we're going to do is we're going to write down what we see. 7 times x, so I'm going to say 7x, minus 4 times y, so minus 4y, is 13. Second sentence, negative 7x plus 7y is 14. Well, let's add them up. Notice, once again, my x's cancel. 7x minus 7x, not once again, but 7x minus 7x is 0. Negative 4y plus 7y, well, that's 3y equals 27. I will divide by 3. Y equals 9. I found y first this time. Now, well, let's use my first equation again. And I'm going to say I'm going to say 7x minus 4 times 9 equals 13. Or 7x minus 36 equals 13. We'll add 36 to both sides, and we'll get 7x equals 49. Divide by 7. We have a lot of 7s in this problem, don't we? And x equals 7. So 7 and 9, since we have x and y here. And that's what we do. Now, what happens if they're not opposites? Well, what we're going to do, if they're not opposites, but they're still the same number, that's what you're going to have today. You won't have anything else. Things more complex we'll do in the next lesson. What I'm going to do is I'm going to get them lined up just like I did before, but then I'm going to multiply one of my equations by -1, so one of my variables cancels. And then I solve it the same way. And we'll do that in the next video.